Hi, everybody, and welcome back to part two of our video series, going through Excel, using Excel rather to go from creating sales forecasts and through the entire process of creating master production schedules, right through to financial results and profit and loss by products. In our previous video, we had calculated forecasts for each one of our months based on our 2019 sales using 4 different forecast models here. In this next section, what we want to do is we need to determine what the variance is between our previous period actual sales from our forecast models. And I like to do that down on the bottom section here. So to begin, what I like to do just to keep everything consistent and easy to follow is I like to just copy the names of my forecast models and just paste them down here, okay? And now we want to start with the variance for the 2-month moving average. This is a very simple process. The most difficult component of this is making sure that we are in the right cell for the forecast and that we're selecting the right cells in the formula. Because it's quite easy to take a previous and then if you're not paying attention, maybe subtract it from a different forecast model. So you don't want to do that. So we'll start here at the beginning for our 2-month moving average. And we'll move over to March because March is where we had our first forecast for a 2-month moving average. So what we need to do is when we're making this calculation, we have to keep absolute cell values. In other words, we don't want any negative values. So for each time we're putting the formula in here to subtract the variance, we need to begin with equals ABS. Okay, you see here that returns the absolute value of the number without its sign. We'll double click that and we'll take March's previous sales minus the 2-month moving average forecast that we calculated and close bracket. So we should have equals ABS, open parenthesis, D10 minus D11. Select tab and we'll highlight that cell again and use our fill handle and drag it right over. And we'll check December and we should see equals, here's our formula bar, ABS M10, which was our previous sales, minus M11, which was our 2-month forecast. So we're good there. We can see that we've returned all positive values, which is what we want. Okay, so now for our 4-month moving average, we put our first forecast in the 5th period, which is May. Here it is right here, 4-month moving average, okay, right there, because we had taken the average of January through to April. Okay, so that's where we're going to calculate our variance. So again, equals ABS, and we'll take our previous actuals minus, here's where you need to be careful. You want to make sure that you're clicking on the right forecast, which is 4-month moving average. Great, that's where we are. So we want to be on row 12 and then close parenthesis. So we should have, excuse me, equals ABS, open parenthesis, F10 minus F12. Select tab and let's highlight that, use our fill handle, drag it across, check our December, and we can look up in our formula bar and yes, we've got M10 minus M12. So we've got the correct column and row numbers there. All right, so let's go down now to our exponential moving average. And we had our first forecast for that. If we go up to the top here, our first forecast was in February, period 2. So this is where we want to calculate our variance. So while we're in cell C19 equals ABS, there it is. And we'll select February previous sales, actuals, minus the EMA forecast here, and close parenthesis. So equals ABS, open parenthesis, C10 minus C13, and we'll select tab. Then let's highlight that, get our fill handle, drag it all the way across, and just double check December here to make sure that your formula carried through okay. Yep, M10 minus 13, perfect. All right, so for our last variance, we're going to use our linear forecast. Now we had our first forecast in the first period here in January. So here's where we're going to calculate our variance. Equals ABS, And we're going to take the previous sales minus our forecast amount in B14, close parenthesis. And we'll drag all the way across. There we go. So we've got all that. And we'll just check this again. Yes. And 10 minus 14. Now, if you want to, you can see we've got some inconsistencies here in the numbers. Some are currency, some are not. What you can do is you can just highlight, for example, any one of these cells in our previous sales, and we can go up here and we can use something called a format painter. Just click that, and then just highlight all the cells in your variance. Take your finger off the mouse, and now you can see they've all formatted nice. So just so we've got some consistency. It's not absolutely necessary, but it makes it a little bit tidier. All right, so for here, what we want to do now, first thing we want to do is we want to calculate the total of our variances. Okay, I'll just center that and bold it. Okay, so we want the total of all our variances. And what I'll do is I'll just start in column B on cell 7 or row 17. And we're just going to add that right up. We can hit our auto sum button here and pull that up. And because this formula here, excuse me, this formula in column N, you'll see that is the sum of column B to M. Because we've taken it over the very first column B here, we don't have to keep dragging, manually creating this formula for each row. We can just grab that fill handle now and drag it straight down. And now you can see we've captured the total for all of the variances, the sum of all the variances for each of these models. And then lastly, we want to calculate the mean absolute deviation, okay, or the average of the total variances. Now, this is quite simple. All we're going to do here is we're going to take the total of the variances, and we're going to divide that by the number of periods that we forecasted it for. So, for example, for the 2-month moving average, if we highlight that, that was 10 periods that we had calculated that for. So our formula will simply be equals, okay, N18 or total divided by 10 periods, okay, and that gives us our mean absolute deviation. For the 4-month moving average, we only calculated for a total of 8 periods. So we're going to divide this number by 8. Our total divided by 8, and we've got our mean absolute deviation there. For the exponential moving average, we have 11 periods. So we will take that divided by 11, and we've got 5953. And now for our linear, our last forecast model, now we've forecasted for every period, so we know we calculated that for 12 periods. That's going to equal that divided by 12. Okay, and we've got 13. And lastly, you want to make a choice. So which forecast model do we want to use? Which is the best fit given this data set, and explain why. So we make that choice by looking at the values here that we've calculated our mean absolute deviation. And we would select the forecast model that has the lowest value, which is the tightest fit. And we can see right here in O20, the linear forecast model has the lowest value. So here we would choose linear model, selected. Okay, explanation, best fit as it has lowest mean absolute deviation. Okay, and that's all there is to finishing this component of the project. So we've created our forecasts, we calculated our variances, and then we looked at the mean absolute deviation of those variances, and we selected the model with the lowest result here as the best fit, And then we made our choice here, and we gave a quick little explanation as to why we chose that particular forecast model. So that's it for this section, and I will see you in the next video.